Greetings and welcome back to the workshop. Today we're going to have a look at the electrics because our variable frequency drive has arrived. So we're going to see if we can hook it up to the motor and get this to rotate on 240. And we shall start with removing the panels on the back to look at the motor. And I've also just noticed there's a panel on the end. So we'll take that one off as well if we can't see the motor in this one. That is a big motor. And I can't see a panel on it either. So we'll open that end one. Oh, excellent. So the plate is right there. Somewhere where we can't see. And this bit down here, this is the foot emergency stop. So you press the pedal, that rotates and hits this switch. So hopefully we'll be able to reuse that switch. So with the wonderful world of modern technology being a camera phone, I've taken a snapshot of the plate. And the plate is telling us that the motor is a three-phase induction motor, which should already be in delta mode, not star. It's a two-speed motor, so it's 1.5 to 2.4 kilowatt, running obviously 380 volts, and the two speeds are drawing 5.4 to 5.5 amps with a revolution of 700 and 1420 revolutions per minute. So hopefully this is going to be a simple job of wiring the motor up. Hopefully. I've removed the end cover, which is just two little thumb screw bits. There's one at the top, one at the bottom, to reveal the end. Obviously this is the power feed section, obviously the main spindle, the pulley that comes from the motor, which has a brake attached. Now down here in this little box with the most awkward screws to get to, because when I lower you down to where the screws are, you can't get to them, so they're going to be fun to get into. This here, there are two micro switches, one at the front here and then one further back. They are for the forward and reverse, so I'm not sure if I need to get into there. Hopefully I can do it through the box at the back. And speaking of the box at the back, here is the electrical cabinet at the back. So in the box we've got the contactors to engage forward, reverse, the coolant pump. This contactor on the end turns the old machine on. You've got the overload relays. You've got the 24 volt transformer. This is to power the light on the saddle and the light at the front of the machine. This also is the power for the contactors. So we don't need the contactors. We won't need the thermal overloads because all that will be done in the variable frequency drive. We'll change the transformer out because that's a three-phase transformer to 24 volt. So a lot of this here is coming out, and I believe somewhere here is where we're going to wire into to check the motor, but we'll have to check the wiring diagram. This here is another micro switch. This is the end cover micro switch, which hopefully we're going to be able to use. Looks very scary, but once you have a wiring diagram, it makes things a lot easier. Right, so hopefully this is coming through. This is the wiring diagram for the lathe. We have the three-phase power coming in here, dropping down to the forward and reverse contactors, which then jumps through a overload relay, which then goes to a switch, which is your switch for high and low speeds, to your motor. And then off your three-phase power, you then go to the coolant pump, which again goes to the coolant pump switch, the contactor, sorry, then to the overload relay, and then to the motor via switching over here, which is all this. This is all your switches, which is powered off your 24 volt transformer. So you've got all the emergency stop buttons and stuff, all that's in here. But for now, we are going to basically take all this section out, and from the 240 volt, which will be coming in, we'll be going to the VFD, which will be here, well, covering all that, which will then go to the switch, then to the motor. So that's what I'm going to wire in now and see if it works. Right, so here's the VFD. We've got it temporarily wired into the machine. We've got a temporary power cable here, and then we have the grey cable wired in, which is the three-phase out. So we have the 240 here on this side, and then this side over here is the 3-phase, which is wired into the machine. In the block where I said before, on the W, V and U, you can just see that at the top maybe. This is the power that goes to the switch at the front of the machine. So it eliminates the contactors and the overload relays. So all that is now obsolete. Now we've got a temporary hookup to the VFD, we can now test if it runs. Now, looking at the paperwork for the variable frequency drive, the only setting that I have had to change is the maximum hertz. The default settings should be perfect for testing. Obviously, we'll have to fine tune the VFD later on once it's all properly wired in, but for now, those will do perfectly. So I shall now press the button and see if this turns. Get your fingers crossed. Hey! There we go, you see? Simple as that. 2 wires. One from the 240 to the VFD to the switch at the front of the machine. Via obviously the board at the back. Press the go button and she runs. Somewhere in the region of 255 RPM. And if I press the stop button, it stops. Now, this motor is a 2-speed motor, and it does that by the switch at the front. The switch at the front goes to 2 different sections of the motor. In one selection of the switch, the wires go to 4 poles of the motor, which gives 1 speed. And when you switch the switch the opposite direction, it then sends the wires to a different part of the motor, which then goes to 8 poles, because it's a 4 and 8 poles. And depending on which one it picks, is dependent on how fast the motor runs. Now the VFD is set for the highest rating. So, if I switch this switch at the front, and leave these gears alone, this should run at a different speed. I shall press the button. And it does. Seems to work. And nothing's gone bang. Now I'm really pleased that this worked as good as it did. Obviously, I've done a lot more testing than I've shown on the screen. You know, we've got to make sure that everything's safe and I'm not going to get electrocuted at the time of a press go. Or the machine, touching the machine, you know, we've got to make sure we're completely safe. If you feel that you are not a competent electrical tinkerer, then please do get a professional in. You know, there's plenty of people out there that can help you. Hopefully this will give you some idea of how to do it to the machine. But if you don't feel comfortable doing it, please do get a professional in. And if you do have a go, and you've done it and you tested it and it's fine, then at the end, please do get an electrical person in to check the wiring you've done. Get him to go over it, get him to check that it's all correct. Nothing, you know, just give yourself that extra security that you know nothing's going to go wrong and nothing's going to go astray. Because at the end of the day, it's electrics and they are dangerous. So please do make sure that you are safe and you have the electrics checked at the end once you've done it. Although it looks like I've hot wired this in, I'm going to try and describe to you what I've done and hopefully it comes across okay. So let's go to the whiteboard. So this is the bit that we've just rewired. So this is what the machine looked like before. I hope you don't mind my crude drawing here. So we have the 3-phase input on this side, which is via a switch, which is sat at the back of the machine. The 3-phase comes in and goes across, and it carries on, and then you get a very similar pattern going to the coolant pump, and then 2 of the phases then go to the 24-volt transformer. But we're not looking at those at the minute, so we'll ignore those on the drawing. So originally, you had 2 contactors here and here, which was for forwards and reverse, which are labelled on the machine KM1 and KM2. Those switches then go, both the forwards and the reverse go to the overload relay. So this here is the overload relay. F R1. From the overload relay it then goes to this switch, which is actually a 3-position switch. 1, off, 2. And depending on which one you go, if you go 1, it will go to one side of the motor, like this side here. So you'll have the 3 wires coming out, connect to the motor, which hits the 4-pole side. Then if you switch it to the number 2 side, it swaps from the 4-pole to the 8-pole side of the motor. So it'll come down these 3 here to the motor. And that's how it basically operates. We are going to a variable frequency drive. So we don't need most of this, and we only need single phase input. So to do that, we don't need the overload relay. And we don't need the forward and reverse. So we don't need this input. And we don't need that input. And we don't need any of this. We just need the live and the neutral. So that's all we need left. In place of the contactors, KM1 and KM2, because KM1 and KM2 are actually contactors, not microswitches. The microswitches control the contactors. Now what we've got is our VFD, which connects to those 3 wires in front of the switch and are now positive and negative connect to the VFD. Now, I know what you're thinking. How do we control the forward and reverse? Well, on the VFD, you will see this. We have some connections called COM, X1, X2, X3, X4 and X5. Now if you change some parameters inside the VFD, COM and X1 will give you forwards, and COM and X2 could give you reverse, and COM and X3 could give you an emergency stop, and COM and X4 could give you the jog. And it's all controlled by the parameters of the VFD. We shall hook up COM, X1 and X2 to the microswitches on the front of the machine. For the switches to work, they need to be in the normally open position, which means there's no contact. So we're going to have the COM, the X1, the X2. If we touch those 2 together with the right parameters in the VFD, it'll work. So let's go try forward and reverse on the microswitches using the VFD and see if that works. Right, so back at the VFD, here are the ports I'm on about. So on the right here is the COM, which is the brown. The blue is X1, the green and the yellow is X2. Yes, I know that I'm not using the right colours, but we'll hopefully sort that out with some of the wires that come out of this machine. And these go to these areas here, which the green and yellow is at number 10, the blue is at number 4, brown is on 7. So that's all in there. So those wires go to these microswitches that are in here, which there are 2 of. There's one at the front, one at the back. One is forwards, one is reverse. They're sort of linked together, which is quite clever once you figure out how that's wired. This part here is connected to the lever on the front. Pushing the lever down moves this block to push the back microswitch, and lifting the lever up pushes the front microswitch. So we'll go turn the handle and see what happens. So this is the lever here, and if we lift it up, the microswitch should switch and that should rotate towards us, which it does, and knock it off, it stops. Now if we go down, it should go away from us. Again, which it does. We go to the second speed, forwards, off, reverse. Okay, so here we are. We have our VFD and our ports, COM, X1, X2, X3, X4, X5, which you saw on the previous little sketch I did on the board. These are the back of the microswitches for the forward and the reverse. Now, obviously one is COM, normally open, normally closed. And on the other way, it's the other way around. It's normally closed, normally open. I've got that wrong, didn't I? That should be COM. Silly me. And the COM. Now, the forward microswitch on my machine is SQ4 and the reverse microswitch is SQ5. Now, how these are wired before we do this is like so. The COM comes in to the COM. It then goes through the switch to the normally closed, so which means it's a circuit. Comes out of the normally closed and goes across to the COM. It then runs through there to the normally closed and comes out and goes somewhere else to another microswitch on the machine. The normally open goes to the forward contactor where the COM runs through as well. And on this side, the normally open goes to the reverse. So that's how it's wired. Very simple, very, very simple. We already know that our COM needs to go to our COM and our normally open needs to go to our X1 and our X2 goes to that switch. That simple. I hope you understand that. So that COM all the time runs through there. Now when you press the microswitch, it then cuts this and connects it to here. And vice versa on the other side. So once you flick the switch in, it then becomes a closed loop and tells the machine to run. And then as soon as you take it out of the microswitch then stops that joint and runs back through the circuit. And then again over here, you press the reverse one and it then joins those two together. I hope that makes sense. It made sense to me. But that's basically it. And then it's the same microswitches. The COM then will go to the next microswitch and the next microswitch and the next microswitch. We're going to have X1 as forward, X2 as reverse, X3 as stop, X4 is jog, and then we should have a spare X5. Now the stop one obviously is going to go through 3 microswitches in total, or 3 switches. The emergency stop button on the front, the brake pedal on the bottom, and the end cover microswitch. What parameters did I change to get that to work? So the parameters that I changed in this to get the forward and reverse to work on the X's is P11. I switched that from 0, which is the panel keyboard, which is this, and I adjusted it to number 2, external port, which are these. These are the external ports, which are X1, X2, X3, X4, X5. In fact, it goes to X6, which are P50 to P55. I switched X1 to number 5, which is wire forward operation, which means as soon as you keep the two together, it will stay in the forward operation. As soon as you break that with the microswitch, it will stop running. And then obviously X2 I set to wire reverse operation, which again, the wires have to be kept together and it will stay in the reverse, which is what those microswitches are doing. The emergency stop one is 19, which kills everything and you've got to reset, start again. And the jog, which will be doing jog forward, is number 17. And then there's lots of other parameters, which if you're familiar with the AT-1, which many home workshop users have got these, they're very basic, but they do the job. Long term, probably not last as long as a decent brand, but when you're on a budget, it's what you go for. So that's the wiring diagram there for this one. So you've got your single phase in, then you've got to your motor, and then you've got your X's and your COM. There. The biggest issue I've got next is where am I going to put the variable frequency drive, because now I know that this works and the microswitches, especially for the forward and reverse work, I know that all the other microswitches that are going to work for the emergency stop or the braking system will work. Now, one thing I do think is it would be completely irresponsible of us if we don't at least put a piece of metal in it and see if we can get something cutting. So we'll just put a bit of metal in. Let's see if it cuts. Now hopefully it's coming across how absolutely silent this machine is. Because here in the workshop it's quiet. It's very, very quiet. We're currently on 510 RPM. The feed rate is 12 thou. Not 12 thou. Yeah, 12 thou a revolution. I think that's what we're set to. I've got to get used to this machine. It's totally different to the Harrison. Nice finish, very nice. We probably could have gone a bit quicker. We'll take a bit off this here, shall we? I do like that on-off switch. It's definitely much nicer to operate. We're going to give a fairly big cut, I think, see what happens. Quite a decent sized cut and it doesn't even sound like it's straining. Just got to get used to this machine. From off the go, that's a reasonable finish. Let's take a bigger cut, I think. See what happens. Slightly bigger cut this time. Again, machine isn't straining. Let's come up to the shoulder. Come up to the even thicker bit now, a thicker cut, and it's not even straining. It's a much nicer finish. There we go. It's roughly wired in and it works. And it cuts metal. I'm quite happy with those results. Obviously I'm pulling bits of metal out of the scrap bin, so I'm not really sure what grade they are, or, well, what grade they are. Now what I've got to do is, like I say, figure out where the VFD is going and actually get it done, totally wired in, and go through everything. I'd like to take this opportunity right now to say a huge thank you to the very kind gentleman, one of our lovely viewers, who gave me a donation via my link on my website, which, thank you very much. It's really greatly appreciated. Another huge thanks to all those that subscribed with the last video of the Warco. I was quite blown away at how much people enjoyed that video and decided to click the subscribe. And if you're one of those that hasn't clicked the subscribe button, then please do, by all means, consider clicking the subscribe button and the notification bell, and you'll be notified when I next release a video, which could be on a machine, or could be on my steam engine, or could be on something completely random. But it's all workshop related. And don't forget to click the like button, because that will help this video and all my others share around to like-minded folk who have exceedingly good taste, just like yourselves. With that, I'll see you in the next video. Hopefully a bit more hands-on. Laters. Suppose I better consider start cleaning it, really. This is going to be a horrible job.